Alright, guys, welcome to today's episode. In today's episode, we'll be talking about storage devices, input and output devices, communication devices, programming languages, and finally about operating systems. Now, let's delve into storage devices. A computer's memory, which is called RAM, is a volatile form of data storage. Any information that has been stored in memory, for example, saved, is lost when the system's power is turned off. Programs and data are permanently stored in storage devices and are moved. When the computer actually uses them, the memory, which operates at much faster speed than permanent storage devices can. There are three main types of storage devices. First, magnetic disk drives. Second, optical disk drives, which are CD and DVD. And the last but not least is USB flash drives. Drives are devices for operating a medium, such as disks and CDs. A storage medium physically stores data and program instructions. The drive reads data from the medium and writes data onto the medium. Now, let's talk about disks. A computer usually has at least one hard disk drive. Hard disks are used for permanently storing data and programs. Newer computers have hard disks that can store from 500 gigabytes to 1 terabytes of data. Hard disk drives are usually encased inside the computer, but removable hard disks are also available. CD stands for compact disc. There are two types of CD drives, CDR and CDRW. A CDR is for read-only permanent storage. The user cannot modify its contents once they are recorded. And CDRW can be used like hard disk. That is, you can write data onto the disk and then overwrite the data with the new data. A single CD can hold up to 700 megabytes. Most new PCs are equipped with CDRW drive that can work with both CDR and CDRW disks. DVD stands for digital versatile disc and digital video disc. DVDs and CDs look alike, and you can now use either to store data. A DVD can hold more information than a CD. A standard DVD storage capacity is about 4.7 GB. Like CDs, there are two types of DVDs: DVD-R, which is read only, and DVD-RW, which is rewritable. Now, it's a time to talk about USB flash drives. USB flash drive stands for Universal Serial Bus. Connectors their connectors allow the user to attach many kinds of peripheral devices to the computer. You can use a USB to connect a printer, digital camera, mouse, external hard disk drive, and other devices to the computer. A USB flash drive is a device for storing and transporting data. A flash drive is a small, about the size of a pack of gum. It acts like a portable hard drive that can be plugged into your computer's USB port. Now we can talk about input and output devices. Input and output devices let the user communicate with the computer. The most common input devices are the keyboards and the mice. The most common output devices are monitors and printers. The keyboard. A keyboard is a device for entering input. Compact keyboards are available without a numeric keypad. Function keys are located across the top of the keyboard and are prefaced with the letter F. The functions depend on the software currently being used. When it comes to a modifier key, it's a special key such as Shift, Alt, and Control keys that modifies the normal action of another key when the two are pressed simultaneously. The numeric pad, located on the right side of the most keyboards, is a separate set of keys, styled like a calculator to use for entering numbers quickly. So, if we talk about arrow keys, located between the main keypad and numeric keypad, are used to move the mouse pointer up, down, left, and right on the screen in many kinds of programs. The insert, delete, page up, and page down keys are used in the word processing and other programs for inserting text and objects, deleting text and objects, and moving up or down through a document, one screen at a time. A mouse is a pointing device. It is used to move a graphical pointer, usually in the shape of an arrow, called a cursor, around the screen or to click on screen objects such as buttons to trigger them to perform action. Now, Let's talk about the monitor. The monitor displays information such as disk and graphics. The user resolution and dot pitch determine the quality of the display. The screen resolution specifies the number of pixels and horizontal and vertical dimensions of the display device. Pixels, short for picture elements, are tiny dots that form an image on the screen. A common resolution for a 17-inch screen, for example, is 1024 pixels wide and 768 pixels high. The resolution can be set manually. The higher the resolution, the sharper and the clearer the image is. The dot pitch is the amount of space between pixels measured in millimeters. The smaller the dot pitch, the sharper the display. Well, let's move on to communication devices. Computers can be networked through communication devices such as dial-up modem, which can be modulator and demodulator, and DSL or cable modem, a wired network interface card, and a wireless adapter. A dial-up modem uses a phone line and can transfer data at a speed up to 56,000 bps, which stands for bits per second. A digital subscriber line, aka DSL, connection also uses a standard phone line, but it can transfer data 20 times faster than standard dial-up modem. A cable modem uses the cable TV line maintained by the cable company and is generally faster than DSL. A network interface card, which stands for NIC, is a device that connects a computer to a local area network that stands for LAN. LANs are commonly used in universities, businesses, and government agencies. A high-speed NIC called 1000 base T can transfer data at 1000 million bits per second. Wireless networking is now extremely popular in homes, businesses, and schools. Every laptop computer sold today is equipped with a wireless adapter that enables the computer to connect to a local area network and the internet. Well, it's the best time to talk about programming languages. Computers do not understand human languages, so programs must be written in a language a computer can use. There are hundreds of programming languages, and they were developed to make the programming process easier for people. However, all programs must be converted into the instructions the computer can execute. Now, let's move on to machine language. A computer's native language, which differs among the different types of computers, is its machine language, a set of built-in primitive instructions. Those instructions are in the form of binary code. So if you want to give a computer an instruction in its late native language, you have to enter the instructions in a binary code. For example, to add two numbers, you might have to write an instruction in binary code like this. Now let's talk about assembly language. Programming in machine language is a tedious process. Moreover, programs written in machine language are very difficult to read and modify. For this reason, assembly language was created in the early days of computing as an alternative to machine languages. Assembly language uses a short descriptive word known as mnemonic to represent each of the machine language instructions. For example, the mnemonic add typically means to add numbers, and sub means to subtract numbers. To add numbers 2 and 3 and get the result, you might write an instruction in the assembly code like this. Assembly languages were developed to make programming easier. However, because the computer cannot execute assembly language, another program called an assembler is used to translate assembly language programs into machine code, as shown in the following picture. Writing code in assembly language is easier than machine language. However, it is still tedious to write code in assembly language. An instruction in assembly language essentially corresponds to an instruction in machine code. Writing in assembly requires that you know how the CPU works. Assembly language is referred as the low-level language because assembly language is close to the nature of machine language and is machine-dependent. The next point is the high-level language. In the 1950s, a new generation of programming languages known as high-level languages emerged. They are platform-independent, which means that you can write a program in a high-level language and run it in different types of machines. High-level language are English-like and easy to learn and use. The instructions in high-level programming languages are called statements. In the following picture, for example, You can see the higher level language statement that computes the area of a circle with a radius of 5. There are many high level programming languages, and each was designed for a specific purpose. And if you want to see about the high level programming languages, see my previous video. A program written in a high level language is called a source program or source code. Because a computer cannot execute a source program must be translated into machine code for execution. The translation can be done using another programming tool called an interpreter or compiler. An interpreter reads one statement from the source code, translates it into machine code on a virtual machine, and then executes it right away, as shown in the following picture. That a statement from a source code may be translated into several machine instructions. When it comes to compiler, it translates the entire source code into a machine code file. The machine code file is then executed as shown in the following picture. Now it's time to talk about operating systems. The operating system, OS, is the most important program that runs on a computer. The OS manages and controls the computer's activities. The popular operating systems for general purpose computers are Microsoft Windows, Mac OS, and Linux. Application programs such as a web browser or a word processor cannot run unless an operating system is installed and running on the computer, as shown in the following picture. The major tasks of an operating system are the follows: controlling and monitoring system activities, allocating and assigning system resources, and scheduling operations. Well, what's the task of controlling and monitoring system activities? Operating systems perform basic tasks such as recognizing input from the keyboard, sending output to the monitor, keeping track of files and folders on the storage devices, and controlling peripheral devices such as disk drives and printers. An operating system must also ensure that different programs and users working at the same time do not interfere with each other. In addition, the OS is responsible for security, ensuring that unauthorized users and programs are not allowed to access the system. Now we can move on to the task of allocating and assigning system resources. The operating system is responsible for determining what computer resources a program needs, such as CPU time, memory space, disks, input and output devices, and for allocating and assigning them to run the program. When it comes to scheduling operations, the OS is responsible for scheduling operations activities to make efficient use of system resources. For example, multi-programming enables you to use a word processor to edit a file at the same time as your web browser is downloading a file. Now, let's move on to multi-threading. Multi-threading allows a single program to execute multiple tasks at the same time. For instance, a word processing program allows user to simultaneously edit text and save it to the disk. In this example, editing and saving are two tasks within the same application. These two tasks may run concurrently. When it comes to multiprocessing or parallel processing, it uses two or more processors together to perform subtasks concurrently and then combine solutions of the subtasks to obtain a solution for the entire task. It is like a surgical operation where several doctors work together on one patient. Alright guys, this is pretty much it for today's video. In the next videos, we'll be talking about Java specifically. Please do not forget to share, subscribe, and press the like button. This was Tech and Talk. Let's go.